Okay, this screencast is going to be looking at solving some more trig equations. We're looking at just some variations now. So I'm just going to take some examples straight out of the textbook, page 455, on solving trig equations. So working from page 455, looking at the example in the textbook, and that is solve. Now this one is sine 2x equals square root of 2 on 2, and this is for 0 to 360 on x. Okay, so the ramp up here is that there's a 2x there, not just sine x, and this also might not be recognizable, this root 2 on 2. Just a reminder that is actually just 1 on root 2. If you rationalize 1 on root 2, you get root 2 on 2. Okay, so that, I'll just put that in a box there. So this is the same as the square root of, 1 over the square root of 2, which is our little right angled, isn't it? 1 root 2, where that's 45. So my angle is 45, but it's 2x equals 45 in this case, not x. So therefore, and if we go and let's just look at the quadrants we're in. Sine 2x equals 1 root 2. It's 45 in that quadrant and that quadrant where sine is positive. And 45 in that quadrant is 135 in that quadrant. Okay, so that's 135 there and 45 there. They're the two angles we're looking at. But this needs dealing with here. So in fact, a good way of looking at this is to say, well, okay, if that's my domain for x, what's my domain for 2x? Well, it's 0 to 720. Doubling here means we double 0. That doesn't change, but double 360 to 720. If that was 3x there, then and this was our domain for x that we need to consider for solutions, then I would be timesing by 3, and that would be 0, 3x, 3 times that, 1080. Okay, so we're going to now consider a solution. So now this is considered as a whole angle 2x, and so this 45 and 135 needs to stretch around to 720. So therefore, 2x is equal to, let's get to work, 45 degrees. That's solution 1. 135 degrees. That's solution 2. We need to go to 720 though, so let's get moving. We've got to get another lap or two into us, don't we? So let's go round again. 360 plus 45. What's that? 405 degrees. So what we can do, just to be fast about this, is we can just add 360 here. Add 360 here, right, to get our next solutions on the second lap round. So 445 plus 360 gets us 405. 135 plus 360 gives us 495. Now I'm going to go around again just to check. We're going to add another 360. So what we're doing in effect is, if we have a look at it, we're just doing little leaps of 360 from there to there and there to there. Now if we wanted to leap again to another 360, then that would so from 405 that would give us 795, but we're now, is that right? 720, that's not right, is it? 360 on that, 765, sorry. So we are now beyond, we are now outside our domain there for 720. So we're not going to go with 765, that's outside our range. So we'll forget that. We're not going to be doing that. So our solutions are there. 2x equals that. But we don't want to solve for x. We don't want to solve for 2x. We want to solve for x. We always want to solve for x. So our last step is now to just divide everything through by 2. So it's 22.5 degrees, 67.5 degrees, 202.5 degrees, and 247.5 degrees. and they'll be our 4 solutions that lie within the 0 to 360 range. So just recapping, with a 2x there, let's change our domain up so that we do pick up all our solutions. In effect, we're going to have to go around a second time. Our last step is to divide through by 2. Let's have a look at another example which is nice. We bring in now a quadratic, and it's on page 456, and we're now solving 2 sine squared x plus 5 sine x minus 3 equals 0, and we're solving this as 5 sine x minus 3 equals 0, just got that right, from 0 to 2 pi. We're solving that from 0 to 2 pi. I hope my battery gets me through to the end of this. Okay, so alright, what are we going to do? We've got to look at this. This is a quadratic. It's like 2x squared plus 5x minus 3. So we're going to treat this, we're going to solve it like a quadratic. We're looking for two numbers here that multiply to minus 6 and add to 5. What we might do, because there's a 2 there, we might say, I know I've got 2 sine x in that first slot, I know I've got sine x in that slot because that gives me my 2 sine squared x. Now I just need to fiddle this, so these need to multiply to minus 3, so I've got 1 and minus 3 are my options. I'm going to go plus 3 there and minus 1 there, because I can see what I need is plus 6 sine x minus 1 sine x, so I've got my plus 5 sine x like that. Okay, so that's just observational. So therefore, right, this is equal to 0. So therefore 2 sine x minus 1 equals 0, or sine x equals minus 3. Now we'll find out in a moment that's nonsense. You can't find a value of, you can't find x such that sine x equals minus 3. In fact, we should know from the unit circle that we're restricted by 1 to minus 1. So that there's no solution out of that. But we're going to pursue this line here, which is sine x equals 1/2. That's okay. I've just there added 1 divided by 2. Sine x equals 1/2. We're now in this sort of territory here where we've got 1, 2, root 3. So it's that angle in there, which is, we're in radians, it's pi over 6. And it's also positive, so we're in those two quadrants there, and we're going from 0 to 2 pi. So therefore, x will equal pi over 6 in quadrant 1, and pi minus pi over 6 in quadrant 2, which is 5 pi over 6. So they're my two solutions, remembering we got nothing out of this one here. So a couple of different types of trig equations to get your teeth into in exercise 13D. So enjoy that. I'll see you later.